So today we're going to cover section 2, and we're going to talk about special right triangles. There's 2 of them. The first one is called the 45-45-90 triangle theorem. And here it's telling us that in this triangle, the hypotenuse is going to be the square root 2 times as long as each of the legs. Now, if you notice here, this is actually an isosceles right triangle, if they ask you to name it. Because notice these 2 sides that have the letter A, these are 2 congruent legs. So these are the legs, they're forming the right angle, and they're congruent. And then our hypotenuse is always going to be whatever A is with square root of 2 next to it. Now, when you're given a triangle like this, all they need to give us is the value of one of the sides, and then I can find the rest. So, for example, if I told you A equals 8, then I also know that this A down here is also 8, and then the hypotenuse is just going to take what A was, which was 8, and put square root 2 behind it. So this is a special right triangle. It's called the 45-45-90 right triangle. Pretty good here? We're going to try an example of, again, finding some missing sides. So now they want us to find the value of x. Now, notice they didn't give me any angle measures. All they gave me was the 90-degree angle. If you remember back to your isosceles triangle chapter, when you have 2 sides that are congruent, then these base angles are also congruent. So this is going to be the same. And you know that if you've got a 90 degree, then what's left for the other 2 angles is 90 degrees together. So this one's 45, this one's 45. Here's where memorizing the relationship of the legs. So the 2 x's are the legs, the 6 is the hypotenuse. Now, when they give you the value of the leg, it's easy to find the hypotenuse. But when they give you the hypotenuse and you have to find the leg, this is where we're going to have to rationalize. So this is why I wanted to cover those last couple questions in the homework yesterday. So what I'm going to do here, remember this is supposed to be A, this is supposed to be A if we use the letters we did before. And now this 6 is actually equal to A square root 2. This is the equation that I'm going to solve. I'm going to take A square root 2. It's been set equal to 6. I need to solve for A. I solve for A by dividing both sides by the square root of 2. It cancels from here. I'm now left with A is equal to 6 over the square root of 2. You can never ever leave a square root in the bottom of a fraction. I need to rationalize. I'm going to multiply the numerator and the denominator by the square root of 2. This gives me 6 square root 2 over 2. I can simplify this. I can divide 6 by 2, and this becomes a 3. So final answer for A is going to be A is equal to the 3 times the square root of 2. So each of these legs is 3 square root 2. So you will need to rationalize any questions that leave a square root in the bottom of the fraction. So be able to find any missing piece given one side of the special right triangle. So this is the first one. Now we're going to talk about the second special right triangle, and this one is called the 30-60-90 right triangle. In a 30-60-90 right triangle, the hypotenuse is going to be twice as long as the shorter leg. And the longer leg is going to be whatever the shorter leg is with root 3 behind it. So the way that you can tell which leg is the shortest, if you recall back, I believe it was chapter 6, your triangle inequality theorems, remember the shortest side is always across from the smallest angle. So A here, this is going to be the shortest side. Then the next largest side is going to be the one that's across from the 60. And then the largest is always the hypotenuse, and it's going to be across from the 90 degrees. So remember, you would look to see what it's across from. So across from or opposite, let me write out the whole word, opposite of the 30-degree angle, that's always going to be A. Opposite the 60-degree angle, that's going to be whatever A is with square root 3 behind it. Then opposite of the 90-degree angle, that's going to be whatever A is times 2. Now, at first I know it's kind of confusing and you're like, oh my goodness, how am I going to keep all of this straight? So normally you would have to memorize this, but luckily for you, you guys have open notes. However, next year, if we are back to normal and everybody's in school and tests are no longer open notes, when you use this again in Algebra 2, you're going to have to memorize the relationship of the legs and the hypotenuse. So one way that I remember it is when I have the 45-45 right triangle, I know I have 2 of the sides that are the same, so that's the one that gets the square root 2. When I have the 30-60-90, I've got 3 different angles, so that's the one that gets the square root 3. But again, somewhere have it down which side is what letter or what radical. Keep track of everything. Now let's just add some numbers to a 30-60-90. So again, pay attention to the angles. Now, the 30 doesn't always have to be at the top. It could be down here. So remember, the 30 across from the 30 is going to be A. Across from the 60 is going to be whatever A is with square root 3. And then the hypotenuse will be always 2 times A. So if I start out by giving you A equals 5, then to find the hypotenuse, I just take that 5 and times it by 2. And then to find the side across from the 60, I just put the 5 in front of square root 3. So if you haven't memorized the relationship of the legs and the hypotenuse, then this problem gets a little difficult. And unfortunately, I picked the same numbers that are in the next problem. Let me go ahead and change the next problem just so we have different numbers. I actually picked the same numbers. So let me change that next one. Yep. Pretty good? All right. Oh. Now, when it's a 30-60-90 triangle, they need to give you at least 2 angle measures. Here they're giving us a 90-degree and a 60-degree angle. I know that that missing third one, if I use my triangle, my triangle sum theorem, where I add up the angles and make sure they equal 180, I can add 90 plus 60, subtract it from 180, and I know this missing angle up here is going to be 30 degrees. Now, notice this time I flipped the triangle on its side. The triangle can be sitting any way. You just have to realize that the side across from 30 is a, the side across from 60 is a square root 3, and the hypotenuse is 2a. Just so we get a different question here, let's change this number. Let's make this number a 7, because I just did the 5 by accident. So the side across from 30 is always a. The side across from 60 is going to be a square root 3. So if a is 7, this side over here, x, is going to be 7 square root 3. And then the y, that's 2 times a. So a was 7, so I'm going to do 2 times 7. And this side, or the length of y, is 14. They're going to give you one side, and then from there you can find the other two.
Oh, so like it's not like we just make it up, right?
Right. So they'll start out by giving one side. It may not be A. It could be the Y that they could give you. They could give you the hypotenuse.
Okay.
So let's try that. Let me change the numbers. So let's say here, instead, let's change it up. 60's here, 30's here. Let's say this time I give you that the hypotenuse is 12. So remember, the hypotenuse is 2 times a. The side across from 30 is a. And the side across from 60 is going to be a square root 3. So to figure out what a is, if you know the hypotenuse was 2a, you could do this. 2 times a equals 12. Divide by 2. And you know the shorter leg is going to be half of that hypotenuse. So a is going to be 6. And then the one across from 60, you just take that 6 and put square root 3 behind it. So be able to solve the triangle given one side, and then you're going to be able to fill in the other ones based on memorizing the pattern.
Will there be problems with trying to find the a square root 3?
Yeah.
If we're just given that one.
Yep. And I'll do that one now too. How about that? Do you want me to give it to you as a square root 3, or do you want me to with a root 3 or not a root 3?
I don't know.
Okay, here, let's try it this way. Let's first do it easy. So let's say, again, 60, 30. Remember, this is a square root 3, and 2a. Let's say this time they're giving us the side across from the 60. Let's say this answer is 11 square root 3. Now, I can go ahead and officially solve this. A square root 3 equals 11 square root 3. Divide both sides by square root 3 to get a by itself. That cancels. So a equals 11. Remember, the number in front of the square root of 3 is just a. So a is 11. And then the hypotenuse is just going to be 2 times a, which is 11. So 2 times 11 is 22. Is it making sense a little bit?
Yeah.
All right. Here it says the diagonal of a square has a length of 6. What is the perimeter of the square? So this chapter likes to bring back a lot of our quadrilateral information. Now, notice a picture is not given, so I'm going to go ahead and draw a picture. So here is my square. I'm going to also draw in the diagonal. And again, you can draw it from either corner. It doesn't matter which. I'll draw it up this way. So if you recall back from the previous chapter that when you have a square, all sides are congruent, and you have 4 right angles in the corners. So by drawing in this diagonal, I have now created two right triangles. All I need to work with right now is one of them. They told me the length of my diagonal here is 6. Now, if it's easier for you to pull it out, we can look at it just like this. Maybe it might be better if I put it the way it's facing for you. Let's do this. I'm going to do the yellow one. These are congruent. This one has a length of 6. And here's my right angle. Notice two sides are congruent, so I can use my, the fact that if I have two congruent sides, then my base angles are also congruent. So they're both going to be 45. So now I need to figure out what these legs are, because the legs are the sides of the square. So again, remember the relationship of the sides in the 45, 40. 5, this is A, and this is A square root 2. I need to solve this equation to figure out what A is. So A square root 2 equals 6. Divide by the square root of 2. And A is equal to 6 over the square root of 2. I need to rationalize. 6 square root 2 over 2 simplifies to 3 square root 2. So that's what A equals. Now remember, we pulled this triangle out, this yellow thing, from right here. Maybe I should do that in another color. Okay, so now this side here is 3 square root 2. So is this one. So is this one. And so is this one. To find the perimeter, I can do this two ways. I can either take 3 square root 2 and times it by 4. Whenever you're going to multiply something with the square root, I'm only multiplying outside numbers. So 4 times 3 gives me 12, and I leave the square root 2 alone because there was nothing under another square root. This is the perimeter of the square. I could have also added all the square roots. So I could have also done it as 3 square root 2 plus 3 square root 2 plus 3 square root 2 plus 3 square root 2. When you add radicals, think of the square roots like variables. So pretend like I'm really just doing 3x plus 3x plus 3x plus 3x, and that would give you 12x. But in this case, our x is really square root 2. So the final answer here, this was just an explanation of how to do it. So when you add radicals, you're only adding like square roots, so you only add the outside numbers. So 3 plus 3 plus 3 plus 3 is 12, square root 2. So you can get the answer either by just multiplying one side by 4 or adding up all the sides. So generally when they give you a square question and they're telling you you're drawing in a diagonal, think that you're creating a 45, 45, 90 triangle. Let's try one last example. This is going to turn into a 30, 60, 90 on the next slide. Pretty good on this one? All right, next one. An equilateral triangle has an altitude length of 5. Find the perimeter of the triangle. So let me go ahead and draw an equilateral triangle. Just draw it like this. I want a square. draw an equilateral. That doesn't look very equilateral. Let's say this one's equilateral. Okay, so we know that when you have an equilateral triangle, all three angles are going to be 60 degrees. I'm also going to draw in my altitude. The altitude's going to go straight down the middle here. And it's got a length of 5. Remember, when you have an isosceles or an equilateral triangle, that altitude is also a perpendicular bisector. So these are going to be congruent, as well as this to this, and then this to the whole thing, because it was equilateral. What I'm going to do here is deal with, and it's also a median, which is also bisecting that angle. So if this is 90 and this is 60, then I know up here, this side's 30 and this side's 30, because it's bisecting that angle. So now what I'm going to look at here is I'm going to pull this out. So I'm going to go ahead and draw just one of the triangles. 30, 60, and I know this is 5. Here's where I got to put the relationship of the sides. I know the side across from 30 is going to be A. The side across from the hypotenuse is 2 times A. And the side across from 60 is A square root 3. Now to find the perimeter, I need to find what 2A is. So I'm going to go ahead and take A square root 3. It's equal to 5. I need to solve for A. So I'm going to divide both sides by the square root of 3. This cancels. A is equal to 5 over the square root of 3. I can't leave a square root in the denominator. I need to rationalize. So 5 square root 3 over 3 equals A. To get 2A, I'm going to take 2 times 5 square root 3 over 3. And then this gives me 10 square root 3 over 3. So that's what the hypotenuse is, which is also the side of my equilateral triangle, because that number goes here, which also goes here and here. So now to find the perimeter, I can just take this 10 square root 3 over 3 and times it by 3. Notice the 3's cancel, so the perimeter is just 10 square root 3. You could have also added all the sides, but it's usually easier just to multiply. If it's a triangle, just multiply it by 3. But I could have also added 10 root 3 plus 10 square root 3 plus 10 square root 3. Remember, when you add fractions, you keep the denominator. So this becomes 30 square root 3 over 30. And then 30 divided by 3 is 10. So you can get the perimeter that way as well. That is it for 9-2. We're only spending 1 day on it, so you only have, the homework is due tomorrow. There are a couple evens on there. So I'll go over those answers with you tomorrow. Let me go ahead and show you those.